You can go with the next speaker, Yemaya Maxi.
So my project was tomography-driven optimization of biofuels, where I focused on using corn roots to learn more about plant root architecture and the root structures. So right here in this image, you can see corn with 3 different genotypes. There's the B73, MO17, and hybrid. It was grown both in gel in a lab and in the field. So the plants grown in the gel could be imaged repeatedly with X-ray tomography at 4-hour intervals. And you'd be able to watch the roots grow. And in the field, the plants were grown, they were grown, but then they were removed from the soil there, and the excess soil was washed away, and then they were imaged. Yes, and they were imaged, and then they were re-imaged, and you can see from the lab in the soil that there are different architectures for plants for like the same kind of plant. So I had 3 data sets of corn to work with. They were all donated from Stanford Plant Science Center. So they were put in an imaging system like this that you see over here. This is a Northstar X 5000 system. So the plants were put in this system, and then from there was 2D X-ray tomography that I had to work with. And I was responsible for creating a tomography view of those 3 root data sets that I had. So I started the data analysis using ImageJ. So we decided to go with manual segmentation because of the low image to noise contrast in the images, in the slice images like you see here. So I got started with ImageJ using their painting and interpolation tools. And right here, you can see a short clip of me using their segmentation editor, going through the slices and outlining it, and then interpolating the data so that everything in between is highlighted. So there's the interpolation function here, then thresholding, an open and close function. But as a result, this is what I got on ImageJ. You can see that there's not a lot of detail, and there is some missing information. So then that's when we decided to switch over to Aviso and use some of their tools, because I found it a little bit easier to work on Aviso than ImageJ. Go to the next slide. So getting started with Aviso, I'm going to compare it to my one of my roots that you see here. So this is a 14-day, 3-inch root. That's what it looks like. That's what my tomography is supposed to look like. But if you look at this 2D slice here, it's kind of hard to see where an actual root is. So yeah, because of the low image to noise contrast, I had to figure out how to make this more easy to work with. So I was able to meet with Ali, who is an application scientist that works for Aviso, and he was able to help us get the most out of manual segmentation, since that was the route we chose to use. We could have done more advanced machine learning techniques, but because of time, we decided to go with manual segmentation. So he recommended using the filter sandbox tool, which you can see here. It's on this image that you see, and compared to this image over here, there is a lot more clarity in this image that you see. So in this slice right here, I already have some things labeled out. There's the corn grain, and then some other roots that are branching out. but looking at this image, I can see that there are a few lateral roots. Zooming in, we'd be able to see them better. So over here, you can see these are more filters. I went through all of them and found that this delineate one worked best for the roots. And over here is a volume rendering of my 10-day 2-inch root. So there's this stem that goes into the corn grain, and the light blue roots that you can see here, there's 4 of them. Those are the prime braces. Those are the braces. And then the dark blue roots are the primary roots that are all branching off. And there are lateral roots here too. You can see one right here, but there definitely are a lot more. If you go back and look at the previous image, all of these tiny things, those are all lateral roots. Also, so this week I have been working with the University of Texas at Austin in a biology and paleontology short course where I've been learning more about data acquisition, data analysis, and visualization on ImageJ, Aviso, and Dragonfly. This short course has been helpful in helping me to learn more about machine learning tools and segmentation, and so that I could switch over from manual segmentation and hopefully save time when it comes to doing segmentation on the roots. The work that I have been doing with my plant roots this summer will show up in a larger project or a new project with collaborative virtual reality. So this can be used to identify the roots more rapidly and to communicate the findings more efficiently. The training sets for this are still under development, but there is discussion with SciGlass, which is a company that helps scientists understand their complex data. Understand their complex data and communicate their findings more efficiently with other scientists. And right here is a short clip of some 3D tomography that was done with this software. This is a fly in this image. So this company specializes in large data sets, which is helpful for plant roots because those data sets are generally pretty large. But not only can you use collaborative virtual reality with things like plant roots, but this can also show up in other fields as well, like the medical field, for example. A surgeon could scan the anatomy of their patient and figure out the best way to do a complex surgery in order to keep, in order to minimize making more damages or doing something harmful that could not go well for the patient. So that concludes my presentation. Do you guys have any questions for me?
I have a quick question.
Mhm.
So you mentioned gel-grown medium and field soil when you work with the corn. What kind of gel did you use? Was that special gel?
Oh, so that was not my work. That was from a research paper.
Oh.
I didn't do any of the growing or imaging. I was given the data sets that were already done.
And you say you have you study 3 data sets. Were all grow in soil or?
Yes, those were all grown in soil.
What was the plant you visualize?
It was corn.
The three were corn.
All 3 were corn.
Thank you.
Thank you.
Any other question or comment?
Yeah, this concept of a 3D, of humans having 3D spatial visualization so they can see things in 3D. One of the LSU professors had a nice publication last year showing that it can be a learned skill. This is based on eye tracking and functional MRI. Jemiah, describe how you felt like your ability to see things in 3D improved over the summer with this project.
Yeah, so first I had no idea what this was, but I am able to, I think it's a lot easier for me, especially when looking at the 2D slices. I notice it a lot more than like I notice what I'm supposed to see better than, I don't know how to word it correctly. But like, I understand what I'm supposed to see rather than, like, I know what I need and what I don't need in my images. Did I answer your question? I don't think that I answered it correctly.
This 3D spatial visualization is kind of hard to explain. You sort of know it when you see it.
Yeah.
Thank you.
Any other comment or question? Okay, there are no more